When you ask people what edge compute is, you get a range of answers. Cloud compute and DevOps with devices and sensors, with semiconductors outside the data center, including connectivity, AI, and a security strategy. It's a stew of technologies that's powering our vehicles, our buildings, our factories, and more. It's also filled with fascinating people that are passionate about their tech, their story, and their world. I'm your host, Pete Bernard, and the EDGECELSIOR show makes sense of what edge compute is, who's doing it, and how it can transform your business and you. So let's get started.
Focus, do not disturb, so I don't get unnecessary blinks and dings and all that.
Yes, the bleeps and the bloops in the background usually are
all of that fun that people that make them feel special. All right.
Yes.
I'm all yours, man.
We're interrupt driven these days. Yeah, cool. No, I'm glad we could connect. Are you? You're in California? I see, like Menlo Park area or something. Or
I am in Mountain View, California. It feels like you're sitting in one of the Google's empty offices when you live in Mountain View. It's like
yeah.
It used to be like massive, all the Googlers with the badges and flashes and bicycles and all that. Right now, it's just empty Google offices. Kind of feels like when you go to Google campus, it's like a little apocalypse. So yeah, Mountain View, California.
Yeesh. Yeah, well, it's similar up here in Redmond, I would say. You know, we have a giant. I'm only about a block from the Microsoft campus, and we have.
I used to go every other, month there, so I know your hood.
Yeah, and beautiful new buildings. Not really anybody in. Not a good time to sort of build a huge new campus, but it's just good for the local economy. It's like a lot of folks with hard hats on and orange vests running around, so that's good. Cool. Yeah, I appreciate the time. Why don't we get into it? Why don't we let me introduce you, Hadi Nahari. Thanks for joining. Sometimes I do these podcasts and I forget to introduce who I'm talking to, and then like 30 minutes into it, it's like, oh yeah. Maybe you can give us a little bit of a background on kind of your backstory and how you got from there to here or wherever here is, and maybe we can get started.
Yeah. So I'm Hadi Nahari. I am, in some ways, like a insecure paranoid. You could say I started my career as cryptographer, as a safety and security expert. It wasn't, called cybersecurity. I started at Netscape. And
I saw that Netscape.
It's all of the cool names. That's, folks who are old to remember that name. It was the cool name back then. It was amazing.
Right. That's right.
Environment, and worked up and down the stack. Sun Microsystem when AOL acquired us, Netscape, there was this company called AOL, if you remember. And,
yes.
NVIDIA, Motorola, some of these big names, really passion and interest has always been safety, reliability, security, all the above. When things are reliable, I feel safe. It's my insecurity is addressed. And I love reliable people. I love reliable APIs. I love reliable investors, engineers, architects, marketing people, cars, hardware, software, stack, APIs, everything. That's my thing, and kind of segue into where I am right now. I quit my very nice and high-paying job after about a week after I married my then girlfriend, and started Cognomotive, and I'm a CEO and founder of Cognomotive, really to just dedicate this passion to something that is tangible, which is making things reliable. We don't build hardware or software or autonomous stack, none of those things. We just measure the health of these devices. We call them equipment health. And we use AI, we use machine learning, deep learning, like anyone does. Feels like saying it's e-commerce in the 90s. Everything had to have E. back then.
Yes.
Right now, everything has to have, generative AI,
That's right.
GAI.
Dot AI. Dot AI.
Yeah,
You gotta get your domain name to be dot AI. That's what I
it
heard.
has to be. You got to have that somewhere. So yeah, but really our really focus and what we do, what we're interested in, is to measure the health of systems, equipment. We stay away from the human part. We just focus on the equipment and systems. And we produce if this thing is healthy, if this thing is happy, and if there's any problem,
Right.
we detect and predict those problems, and we provide recommendation as to what to do with it. Should we leave it? Is it okay? It's kind of okay. System is still, operating, or is something,
Right.
problematic? And then we provide guidance to technicians,
Right.
what to do with it, fix it, and all that. We don't fix the problems, we find.
Sure.
So, in a nutshell, it's your McKinsey called it predictive and proactive maintenance. So we do that. And on top of that, one of our differentiators is we also provide guidance. So we don't leave the poor technicians, as, okay, something bad has happened, but
right. The engine light comes on, and
yeah,
who knows?
It's like tough luck. Yeah, we're gonna tell you something bad is about to happen. It's like brain surgeons. They're really, really accurate and absolutely helpless. It's like they're gonna tell you exactly in the 72 hours you're gonna be paralyzed, and there's nothing we can do. So we kind of don't do it that way.
Right.
We accurately detect and predict problems, but we also recommend what can be done. Here's our thing. That's where the AI thing comes in.
Yeah.
But really, that's what we do. That's what our passion is.
It's interesting you mentioned that. It's interesting. I was talking to Stacy Schulman from Intel recently about kind of the pervasiveness of edge computing. So we use this term edge computing. It's kind of I call it it's a bit of a Rorschach test. Everyone has their own sort of perspective on it. But she was saying, yeah, I mean, you walk around, go into a hospital, look at all the equipment there. That's all edge computing. You go into the supermarket, all those self-checkout stands, and we somehow maybe don't appreciate the ubiquity of all these devices and systems that we're now totally reliant on a daily basis. Like you said, they have to be reliable. Probably the people are the most unreliable part these days, and but how to get these systems reliable and predictable in terms of their behavior and maintenance seems to be, kind of a tough nut to crack, right? I mean, there's a lot of things that can go wrong, and I guess the one of the areas I saw from your website that you had been involved with a lot is automotive.
Yeah.
And I think that's kind of a huge frontier these days. Talk about making sure things are reliable. Has that been consuming a lot of your cycles these days, the automotive market, or what's the hot area for predictive maintenance and sort of anomaly detection and things like that?
Predictive, proactive, prescriptive, all of that. Let me take a quick step back. What you mentioned is insightful, meaning everyone and their cats has got their own definition of edge computing. And I remember Cisco came in when I was at NVIDIA, and they said, we got this fog computing.
Oh, right. I remember that, the
awesome.
fog, yeah.
So, you talk to mobile network operators. They, from their perspective, edge is the edge of the network.
Yeah.
You talk to embedded people, and we didn't call it edge. We didn't call it IoT. When I was at Monte Vista, we called it just, embedded computing. It's
exactly.
Edge is endpoint. So from our perspective, when I talk to non-mobile network operators, non AT&Ts and Vodafones on the world, we refer to edge as that endpoint device. In the case of the car or any vehicle, it's that little compute or many computes that exist in that vehicle.
Right.
In the case of factory floor robotics, it's like any compute that is in that, anything that is not really cloud, whatever. Now, you're in the cloud a little closer to the edge, a little deeper in AWS, Google Compute, whatever. So that's for us edge. I just try to kind of consciously switch to now these guys call edge the edge of their network when I talk to the mobile network operators, MNOs. So I wanted to clarify that in this context. We talk to the edge as that endpoint. Same thing. I'm with you. We don't necessarily only work with automotive, but as a 10-person startup, you're nothing but your focus. So we are very primarily focusing on automotive sector for a variety of reasons. It's got a lot of addressable problems that the market has gone through a lot of changes that from the business, technology, all of those perspectives, it requires attention. And the other part is up until like recently, every kind of fancy schmancy advanced kind of work that was done on the edge was kind of skunk work and science project in these R&D parts of these cars, except for this little company called Tesla that no one thought that they would make it. I'm talking about the company Tesla. I'm not referring to its, CEO. I separate that, Mr. Musk and everything. People who want to know what I think refer to my post on LinkedIn. I'm specifically talking about Tesla, the company, and Tesla, the automotive. And everybody else was kind of looking at all of these advanced things and the car autonomy and everything. Realistically, all the automotive vendors, it wasn't serious. There was the R&D. They had to have some sort of presence there. They got to show cool things in CES. But really, when you talked under NDA with them, they're like, all of this autonomy and all of that, whatever. The action happens in Germany, in Japan, and South Korea and everything. And they were not releasing cars with all of these sensors. It was nuts. Therefore, everything. Why am I sharing this with you in response to the reliability? Let me bring it home. Therefore, everything that was the enemy of reliability was already very nicely addressed. The world was very reliable. We had this thing called AutoZar. We had you don't touch things that are in the compute. You design something, you test the crap out of it for like 2 years, release the product. If there's anything that fails, Bosch, Denso, Eisen, and others provide you this nice DTC diagnostic trouble code. And the systems tell you when they fail. You don't need to do anything else. It's all good. It's all certified.
When the smoke starts coming out, then you know there's a problem.
And everyone would show that, hey, take a look at our repair history. We are reliable. We don't need any of these things. To a certain extent, they were right.
Yeah.
Meaning, if you don't add any of these fandangos that we have been adding to the vehicle, Jensen Huang famously called it, the vehicle is becoming data center on wheels. Never going to be data center on wheels, but Jensen said things like this. When you got the $3 trillion company on the face of the planet, you get to say things like this. And he's awesome. I learned how passionate a founder CEO is when I worked for him. In a certain way, it was right. Now, when you add all of this fandangos, software, sensor, LiDAR, all of the semi-autonomy, advanced driver assist system, ADAS, all of those things. Now that world starts to change really rapidly. The very reliability and safety and conservative sort of engineers of the world in Germany and Sweden, in Gothenburg, they started saying, okay, this is nuts. We're not going to do that in our vehicles. And they resisted for quite some time. And one thing they got right, the other thing they got terribly wrong. They got it right that autonomy is not going to happen. I don't believe in my lifetime I'm going to see 40% of the transportation in vehicles fully autonomously. It's just not going to happen. I don't think even in 2030 it's going to happen. Maybe in some restricted areas on tarmac and
fixed route type of things.
Fixed routes, fixed area and everything maybe. So they got that right, but the thing that no one got it right was electrification. And here's the cool thing: how that relates to reliability. The OEMs realize that when they yank out all of that engine, internal combustion engine, ICE, and transmission, majority of the vehicles, passenger vehicles don't have transmission, all of that, they don't put back just the battery pack and electromotor. They have to put a lot of software. This thing is going to come in by definition with a lot of sensors and everything. They got to do it, otherwise they're continuing losing market share. And with this unwanted push to advancing the tech, not towards autonomy, towards electrification, a lot of other things came in. Now they can't hire software engineers and better software engineers fast enough. Now they can't get their hands on, camera, object camera, and sensors and lidars and all those things, fast and cheap enough. With that, the first enemy of reliability, same thing for security, is complexity.
Yeah, yeah.
They are adding complexity. They are adding a lot of software, and all of
Hmm.
these things. It's not automotive vendors. Software is not their forte, let alone data
That's for
science, let
sure.
alone
Yeah.
all of it. So that is kind of why. Long way to answer your question. TLDR. Yes, it is consuming our attention a lot because there's a need, and also there's another thing. It's a lot easier to control humans around the factory floor robotics or
Hmm.
aircraft engines. It's once you add all of these in the largest IoT in the humanity history, vehicles, and a
Hmm.
human is in it, around it, in the passenger and driver's seat. The when you mess things up in terms of safety, security, reliability,
Sure.
you're gonna feel it. So that's
Yeah.
kind of why, yeah, we
Automotive's a
spend a
hot.
lot of time on
Yeah.
automotive.
Well, and also you have the fact that, I mean, let's be honest, a lot of people aren't very good drivers either. So you've got not only, kind of the safety issues around something moving at 60 miles an hour that needs to be, safe and reliable, but you also have this person behind the wheel that maybe is not very reliable either. So,
Yes and no. Yes and no. I want to touch on it, not be reactionary, but
mhm.
there is one thing as to you are correct. The assertion as to humans are not really good drivers in one aspect is really true. Take a look at death by drivers and caused by vehicles,
Mhm.
numbers. But there is one corner that some people abuse knowingly or unknowingly as to it implies as if machine is gonna be better driver than a human. If by implication someone wants to make that conclusion as to therefore machines are really good, that's a really slippery slope because
Sure.
the data
Yeah.
suggests that machines are awful at doing this.
Right, right. Yeah, I mean, there's all those, interesting paradoxes there. I think the what you were saying about the automotive business. I mean, the sheer complexity of the systems. You've got a lot of interesting things going on there, right? I mean, I'm somewhat familiar with General Motors and some other things. My brother's actually worked there for like 37 years, so
I'm so sorry. He's
I
still
know
alive,
the
right?
whole culture there is kind of like very traditional culture, and like you said, you get something there, you get it to work, and then don't touch it until it breaks. And so I think there's been like a really interesting sort of cultural thing, very ripe for disruption, that whole market. And obviously Tesla came in and did a lot of that. But now the systems, like you said, these are not software companies, but they've had to very quickly become software capable companies.
Hmm.
Think about software development, deployment, release, maintenance, all the things that a lot of other companies have been doing for a long time. So cultural changes, organizational changes, technological changes. And it's a huge market. I was talking to someone who was in China recently. I don't know. There's over 100 automotive manufacturers in China alone.
450 and
450. Yeah. I mean, it's incredible.
consolidating. Yeah.
Yeah. I mean, obviously, yeah, they'll have to consolidate there. But yeah, it seems like it's funny. I'll tell you a little anecdote of a very non technical failure. So I have a 72 Volvo 1800. So it's like this little tiny little coupe. And
Amazingly reliable. Those
very
things.
reliable. Although I
Mhm.
was feeling fourth gear one day, it was like a little crunchy. It was a little crunchy.
72. Come on, you got to give it to him.
And it was getting a little crunchier and crunchier, and ultimately I had to replace the transmission. So
Yeah,
so my anomaly detection was like my right hand feeling the crunch of the gear,
works
getting
every
a
time.
little, yeah.
Yeah,
And it was definitely a reliable system to detect anomalies.
yeah,
Unfortunately, it was a multi-month
yeah.
effort to kind of get that thing swapped out. But yeah, no, I like driving the old cars too because you have the pretty analog
Feel
experience
everything.
there,
Yeah, yeah,
and you are viscerally connected to the road. But
mm,
the cars today, yeah, and automobiles, whether they're like you said, commercial vehicles on fixed routes or these personal vehicles, the amount of systems there that need to be upgraded and really kind of thrown out and replaced is tremendous. So
yeah.
when you guys look at a system like that, I mean, is your stuff deployed like throughout like the CVC and some of these other components and
Mm,
the IVI, et cetera? Or are
mm,
there's like I don't know if people know, there's these different subsystems within an automobile, the central vehicle controller and
mm.
all that stuff. Are you focusing on, and also I was curious, like, how does that connect back into the cloud? And are you running like AI models against some of this data that you're measuring and kind of in real time, I assume, right? This has to be pretty deterministic.
great question. Great question. I will just put all of this in context very quickly. Let me very quickly make a plug in and comment on the GMs of the world, GM, Ford, Mercedes, and others. There is one thing, and it's very easy to kind of I don't know, criticize them by, hey, they're like, not advanced and everything. And some of them they deserve. Any incumbent deserves it. But keep in mind, especially when it comes to, such a sophisticated and advanced and complex system, which is a system of systems, like a vehicle. It's the most complex device that humanity has created at this scale. Way more complex. There's 16,000 different components on average, from the plastic, lug nuts and everything in a vehicle, all the way to, very, complex LiDAR, things like that in a vehicle. There is one thing to build a single vehicle that kind of goes in a Stanford around the track and, does something really fancy and create a beautiful video and then raise $100 million capital and burn it in 2 years. There is another thing to be able to pop out at every 60 seconds, pop a vehicle out of manufacturing floor.
At scale.
And satisfy the unbelievably complex supply chain that expands from deep parts of China all the way to, Western and Eastern Europe and all that, and maintain the same qualities, ISO 9000s, and all that, year after year, model after model. You got to give it to the GMs and Fords and others. And one of the magics that Mr. Musk did with, in such a short time with Tesla is still catching up. Quality is crappy in their product, but that's a different issue. It's a different thing. It's similar to AI, and I come back to your point quickly. Similar to AI, assembling something that is really impressive on a website, really, really easy, but creating a product out of it, which is, repeatable, which really addresses the real problem on scale, is a different, phenomenon. So people, investors, entrepreneurs who are in this field, they understand the difference, massive difference, really, really well. So I wanted to just mention that, it's easy to criticize those large companies, but once you go to a factory floor, once you see what it takes to assemble this and how complex just a floor from end to end is, it gives you a different appreciation as to why they resist some of the changes, because change is bad. To answer your question, now what do? The vehicle, as I mentioned, is system of systems. It's not just one computer, one chassis. There are many electronic controller units, ECUs, little tiny computers with different capabilities in the vehicle. On average, between 60 to advanced vehicles, maybe 160, 70 of them. There are different connection, networks. They call them CAN bus or FlexRay, or these are like little networks that these tiny computers are connected together, usually on average, between 8 to 10, 15. Some of them, trucks have more. Each one of these computers, some of them are, microcontrollers, very, small things. They just move the window up and down. Some of them just, move your windshield wiper. Some of them are more sophisticated. They're a full-fledged computer, like an in-vehicle infotainment, which kind of is a misnomer these days. It's not just for infotainment. It's actually a central, computer, as you mentioned, CBC, things like this. There are some, some of these components that are less sophisticated, some that are more sophisticated. To answer your question, we do a couple of things. There are a number of configurations. One of the things we do is when we are embedded in the vehicle, sitting in one of these systems, we really don't care which one, so long as there's access to data. We're data monkeys. Usually that component is called connected gateway, where it's kind of like a gateway, sits in between many of these connecting networks, CAN buses and everything, and kind of sees different traffic. Sometimes we sit there, our customers embed us there. Sometimes there is, they already have their device called telematics. A lot of, fleet, they have this little device that telematic kind of installed in the vehicle. Measures a lot of things. Sometimes they put us there. So we have this edge AI component. I come back to it, which sits there. That's one configuration. Wherever in this system of system we sit, that configuration is embedded. Pros and cons. Once you're embedded things that you mentioned, like real timeness, anything that happens right there and then you see it. You won't encounter the case that I go to the mechanic. I'm like, this vehicle really sputtered like 10 minutes ago. So I don't see it. So you get to see all of those things.
Yes.
You get to kind of assess on the fly things like that. But you gotta someone has to put your software there. So it takes getting to the customer, getting to the endpoint has got more business challenges.
It's a lot of integration too.
And, you got to be integrated. So, but once you're there, we have done a number of these for our customers. Things are really good, and you got like real time. It's like going around with your own X-ray and MRI on your back. The moment something happens, you are able to kind of see. Did I just run fast? So I'm good. The heart rate is going up, but I'm good.
Right.
Or am I about to have a heart attack? So I got to go to ICU. Things like that become apparent. In the cases that you are having safety critical or impact to the equipment is very expensive, or impact on logistics, whatever, it makes sense to have this embedded. In reality, in about 10 years from now, all the vehicles will have a version of this embedded, cognitive or not in the system. It's just the right thing to do. Right now, it's a matter of logistics and getting it into the integration flow. That's 3-4 years for typical manufacturer. That is one configuration.
Yeah.
This configuration is not our de facto configuration because of the business challenges, integration challenges that we mentioned. The second configuration is, remember, we're a data monkey. Many of my customers, fleet OEMs, also dealer networks, they already have collected data from the vehicle. They have access data from the vehicle. They have different type of data from and about the vehicle. Textual data. Someone says this vehicle has got a little vibration in the front part of the chassis. Or I see red engine light coming up. This is just textual. It's called, a customer description. Or a technician takes a look at it. It's like, I think we got to take a look at this recall item. So this is textual about the vehicle. They connect the probe and they capture freeze frames. Something bad happened. And ECUs usually, store that kind of screenshot of the traffic, and you capture that as freeze frame. And number of other, different, flows from the vehicle. So they already have it, either at the point of service or, about the vehicle. What they do in this second configuration, we're not embedded, we are in the cloud. They just plug in all of that, throw it at our system. We do our magic. And we tell them based on this data, and this is from, just the textual data all the way to all of the sensor and raw signal data. That's part of our differentiation. We're able to tell them what the problem is, what are the parts and labor required for this, labor codes and parts code and everything, and what they need to do, what is the procedure to fix them, things like this.
Right.
So in this case, we are using the same backend, the same exact cloud part, but not having direct real-time access to the vehicle. From our perspective, and I shut up after this, from our perspective, really, it's the same thing. Our models are the same. Our flow is the same.
Sure.
How frequently you get the data is really the difference. If I'm in the vehicle, our model is I'm getting a flow of this data continuously, frequently, and the data recency is high. When I'm not there, every month, for the fleet, every week, for the rental cars, every 2-3 days on average, I get this data. The task is the same. It's just what is the delta from one data point to another data point? That's what we do. Really,
the richness of the data. It's sort of like so that's pretty cool. So you've got sort of the embedded version, which I agree is kind of it's a bit of a lift to get that integrated and deployed, and it takes many years. And then there's this other one where it's sort of like, it sounds like it's sort of like an AI powered Mr. Goodwrench or something like that, where a mechanic or someone can kind of.
We call it Kyra. Let me plug in Kyra, cognitive AI repair assistant.
Kyra. Okay, good. That's a good one. I can remember that. That's cool. So it's sort of like now you're taking AI and the cloud powered AI and looking at like time series insights as well as like, like you said, frame pictures of the data over time or in an instance, and then you're probably, hopefully, I don't know, it'd be interesting. Are you comparing it to like other car, or like the same car that, the same model? I mean, is there that kind of like intelligence yet out there where you can say, oh, this is a
Here's
72
exactly.
here's a 72 Volvo, it's got this issue. All 72 Volvos, if they have this data, that means the transmission's about to die. Just to go back to my example.
So up until right now, really what we have been discussing was, data acquisition.
Yeah.
And those data acquisition systems have existed, for many decades. It's like we just talked about, data acquisition.
You're talking about the ODB, like the ODB port on cars? Like
OBD2, onboard diagnostic and everything.
Yes.
That provides data acquisition. Direct connection of the probe is data acquisition. When some technician or customer calls in and says, my vehicle is not really operating well, that is data acquisition. All of these are different modalities of the data. You take a picture of the, smoke and read out a, sensor data and all that through OBD2 or not, whatever. But all of that is in the really, you're just data acquirer. Now the magic now is, AI happening from here. Up until now, you had business analytics, you had business intelligence. Remember the days that calling artificial intelligence AI was a taboo? The first 3 generations of AI, a lot of people promised a lot of things. It was a bad thing.
Yes.
And we're kind of about, halfway there in this generation as well.
Yeah.
But I'm digressing. So up until now, we talked about, data acquisition. The magic right now happens in what you just said. Now, with all of this data, with the recent, current systems that we have, advancements in understanding and processing textual data, understanding and processing another textual data is also similar to time series. It's a form of time series. When we talk, it's in a sequence of the words and letters that we use. Another, raw data time series, canvas and everything. Stored, data, like the freeze frame, like, I don't know, rare event, numeric data, pictorial data, all of those things, combining all of them together, which is, multimodality that everyone is right now just looking after. So we have a solution for that. And another thing, which is, we have this other solution. It's called CHAI, Cognitive Hybrid AI.
Yes, I saw that. That's another good acronym.
It's like
You're
now,
good with the acronyms.
Yeah, it's like when you go to a doctor, we kind of like acronyms. When you go to doctor, the doctor doesn't go to a medical school just for you. Right. Has gone to medical school, has seen many patients similar to you, and is able to extrapolate, is able to kind of learn from one patient throughout the residency and apply part of that knowledge to another patient. So systems that we have do the same thing, meaning I don't need to necessarily create, model per vehicle. That's just death by, 1.1 billion cuts. We get to do some cool things, which is, transfer learning. I learn from one system, I apply it to another one. Another cool thing, which is in order to, learn things, because our systems, any AI system is a learning system. It's instead of being told what to do, it learns what to do. Really, that's really what is happening at a high level. And the way to learn is a lot of this data is more than 95% of the data is thrown away at the edge. A lot less than 5% of the data that is generated every second finds its way to the cloud. So a lot of this data, which is in these edges, in these equipments, are kind of generated, time series and all those signal and everything. They're just dropped on the floor, on the road. So what we do is having these edges, having these systems, we're able to not only learn from one applied to another, not only learn from a fleet and, cluster of systems and apply to one specific system, not only, increase the accuracy and everything. We just need to see events only once. So in the beginning, we're not as smart as a shop foreman, but our systems provably and, measurably very quickly learn things in a very, machines do it. I'm just raving and bragging about the AI. Sorry, I'm next to a Moffett and
I see. I hear an airplane there.
Helicopters are right now having fun here. So, and that is when the actual, machine learning.
That's AI the magic there.
Now that is where we come to picture as to the real value is there. And
Yeah.
I tell people as a joke, it's a if it's on PowerPoint, if it's AI. If it's on Python, it's machine learning. So it's really we're talking about machine learning.
Yes, yes. No, I think that's amazing. And like when you start to sort of, like you said, the collective learning, once you start seeing, multiple vehicles of the same model or same symptoms, I love the idea of some sort of aftermarket system that people could use to sort of keep track and do predictive maintenance and diagnoses of their vehicles. Not sure if it would be super applicable to my 72 Volvo, but because I don't have an ODB port, but things like that, that's fascinating.
Well, 72 probably not.
I don't think there's an ODB on that one there. But no, it's what you're saying is like, basically the data is coming in lots of different forms, right? Like you said, it's sort of visual, it's digital, it's all kinds of things. And then, the magic is really how do you kind of synthesize and look at that data to find patterns or anomalies to patterns that say, hey, there's a problem here, or there's, too much current on this or whatever, that's going to be, something that's going to fail in the future, or maybe something needs to be looked at. And that seems to be sort of a universal thing, right? It's like, I mean, any of this equipment would really need to be monitored either in real time or post facto to kind of gather that data. And of course, every time you're analyzing that data, you're making the system smarter because it's learning, these patterns over and over again. So, yeah, no, that sounds pretty exciting. I think
you realize one thing, if I may,
mm-hmm.
Everything that I mentioned, going back to the first question you asked, everything that I mentioned is applicable to other embedded systems.
Right. Sure.
There's nothing specific about the vehicle except for scale. And that is part of the reason that we don't say automotive is just for automotive. It's this methodology, this way, this style of applying technology to create assistance for technicians, not replacing them. We don't replace my first class citizens are the blue collar technicians. That's who we cater to. This applies to all the technicians because they're overwhelmed by the advancement in technology. They are really quality driven, and they're financially motivated to do a quality job. If the comeback, which is you get your car to fix, and you pick up the car in a day or two, and either that problem is not solved or it caused another problem, that's a terrible thing for them. They don't get paid by that. It's a bad reputation, and all those bad things happen. So we eliminate the comebacks. We help them do their job, and we make them, help them make more money. We tell them our motto is do more, make more. And that is not specific to automotive. That is very, pertinent to any
sure. HVAC repair,
MRO.
Any of that stuff.
Maintenance, repair, overhaul. I could say the same thing about, MRO, maintenance, repair, overhaul, operation of aircraft. It's much more regulated, but the concept is the same. So our job is to use data to create an assistant, which is Kyra, and provide them guidance, detection and prediction problems, diagnosis, prognosis, and also help them what to do to fix it.
Yeah. And it's sort of like, and I think that's kind of where we can go into a whole AI thing here, but people get freaked out about AI replacing, but really AI, when it's well done, is supercharging people's capabilities, giving them
Andreesen Horowitz, Mark Andreesen last week just figured that out, what we have been doing, for 4 years with Kyra, which is, oh my God, the best, use case. I'm saying it jokingly. I got great respect for them as a startup founder, never poke fun at VCs. Yes. It's like this assistance is one of the most prominent use cases of AI. Whoever said that AI is going to come in and replace humans was either ignorant and uninformed, or they had other intention. This is the stupidest thing. We do it day in, day out. I can tell you, we are generations, not just one generation, generations from any AI being able to replace any part of the human. I'm not worried about that. I posted this on LinkedIn a couple of days ago. I'm not worried about the dangers of artificial intelligence. I'm a lot more worried about the dangers of natural stupidity than
yes, there's the natural stupidity paradox. Yes, I agree.
Yeah.
But no, that's interesting. I think that that's definitely, like, Microsoft uses the term co-pilot, which is I think that's a nice phrase. And in GitHub and on now in Office
Yeah.
and other things. But it's like, yeah, how does AI supercharge or give you some superpowers to do what you're doing better and leverage, your skills, especially like mechanics and stuff. I have a guy I go to in Ballard who's all he does is vintage Volvos, and he's kind of the Volvo whisperer. And ability for him to, with his hands, you can't see because I'm not on camera here, but
Yeah.
the hands-on skills are incredible, and so to be able to supercharge that with more knowledge in the background is pretty key. So
Agreed.
yeah, totally cool. Any kind of closing thoughts on what we talked about, and what people should be thinking about when they're thinking about reliability and anomaly detection, as I like to call it?
Yeah, there's we could go on the technical parts of anomalies, and not every anomaly is a bad anomaly. I tell people that you go down 101 or I-95, whatever, the first time that your vehicle is going 110 miles an hour, that's an anomaly. It's not necessarily a bad anomaly. It's an anomaly. It's just the first time that your system has done it. It's anomalous, but it's not a bad thing. So anomaly detection is prerequisite to bad thing. Not all the anomalies are bad. So being able to perform anomaly detection and also then identify, is it a bad anomaly and good anomaly? That is the real thing. By just being happy that I identified the anomaly, it's not really useful. The other thing, which is kind of on the one side, it's a bad news, because it's like, oh, we haven't solved that problem. On the other side, it's a good news as to how limited these systems are. I tell people that, there is one side of data science and AI and machine learning and all of this jazz, which is, we get this data. It's we don't tell people in our Medium articles. A lot of blogs are like this, which is this data is really nicely tabulated, very clean, perfectly labeled, beautifully organized, and then this writer, runs a metric, an algorithm, a code, and first time it's like, shit, this is not working really nice. Modifies the data. Apparently some presidents in Stanford did the same thing on their data as well. They do a lot of, massaging and polishing and modifying and everything, and it becomes beautiful, and it shows, look, I'm able to detect based on the rate of your typing who you are better than your fingerprint.
Right.
And people, start losing their, as to, oh my God, AI is just taking over the world. What they don't see, what is not written, is how much work is required, what are the prerequisites, how clean this data, how theoretical all of this is, and how unrepeatable many of these things are. We come across many of these claims day in, day out. On the one hand, it's like you gotta really not be worried about AIs taking over. We're like generations from that. Whatever works has been really so far helping, whether it's in the edge or cloud, I don't care. Has been really on the helpful side for some good reasons, because in order to apply any technology, machine learning, deep learning, analytics, AI, software, whatever you want to call it, you have to, address a real problem, not just come up with a solution for a problem that doesn't exist. It doesn't scale. You have to have something that is repeatable, and, welcome to capitalism. It has to make money. Many of these things are theoretical and are designed to steer fear, or designed to get clickbait and everything. So look at it, with a little bit of, big rock of salt, and see if any of them has in reality gotten anywhere close to the real world. The data in the real world is nasty, is unbelievably noisy. It doesn't come with labels. The data that is running in your canvas or the Tesla's canvas, doesn't matter how old or new the cars are, doesn't have a nice label as to I'm a bad data, I'm a good data. So you can't run, supervised machine learning, things like that. The data is unbelievably high rate. It's like one autonomous vehicle on average generates 1 terabyte of, signal, raw, nasty data on an hour of driving on average, things like this. So that we don't even have processing ability to process that much data on a, big ass server, let alone on the edge device. So many of these problems, TLDR, that people are scared, when I talk to them are really theoretical,
Sure.
but they do see like, video on TikTok or something, and they get scared. And I'm not that scared. I'm still much more scared than natural
I think
stupidity
that's
than
a good way to
artificial
close it. I
intelligence.
think you're
That's my
right. It's
closing thought
and
for
also
you.
like you said, working back from the actual problems being solved and what's the real value for the business or the customer, and then like you said, the reality on the ground with all this noisy data and stuff is it's complicated, and no one should underestimate that, and try to avoid the TikTok stuff. But yeah, I hear you. Cool. Well, no, okay.
Yeah, yeah, yeah. Or just
Exactly.
look
Yes,
at
it's
it
entertainment.
and have fun and
Entertainment
enjoy
value.
and move on. Yeah.
Well, Hadi, thanks a lot for the time. I think it's been super educational for me, hopefully for the listeners too. And it sounds like you're really in a fascinating space, and a lot of probably interesting projects ahead too. So hope we can keep in touch.
I look forward to it. It was fun chatting with you, Pete. I really appreciate your time and attention, and I'm very open to chat with you again. And hearing about any of these comments from your listeners. I listen to your podcast, and it's very informative. And I look forward to continuing the conversation with you and listeners going forward. It was really fun. I appreciate it. Take care. You too. Bye.
Thanks for joining us today on the EDGECELSIOR show. Please subscribe and stay tuned for more, and check us out online about how you can scale your edge compute business.